Okay, Sam wants to buy a new smartphone. The phone is on sale for 60% off the regular price. If the sale price is $124 after you got the discount, what was the original price? So here is what we know. Everything starts at 100%, but we're going to get 60% off of that 100%, which leaves us at 40%. So 40% is the percent that you are paying for the item. So 40% of the original price is the sale price. So 40% as a numeric value is 0.4. We don't know the original price, so we'll use a variable for that, and that is supposed to be equal to the sale price. And we know that the sale price is $124. So we could use that very simple one-step equation to figure out what that price would be, the original price. So if we divide both sides by 0.4, we've got our one that we were trying to make right there. And so we now try and figure out what 124 divided by 0.4 is. You are allowed to use a calculator on the standard. And so when you divide that out, you will figure out what the original price is for that item. And that happens to be $310. So that means the original price of the item was $310. In this problem, Stephanie bought a new smartphone for $144. That was the increased price after a markup of 20%. Now remember, stores, when they buy something from a different company, they have to mark it up so that they can actually make a profit. So we're trying to figure out what the price of the phone was before the percent increase. So remember, everything starts at 100%. We're going to mark that up 20%, and that gives us 120%. So here's what we know. 120% of something that we don't know, and that was the original price. We know that after that, that's $144. So 120% as a numeric value is 1.2. We don't know the original price, so we'll use a variable for that, and that is supposed to be equal to $144. That's a simple one-step equation. If we divide both sides of that equation by 1.2, and we were trying to make 1 right there, and we did that. And so now we can easily, using the calculator right here, we can figure out what that original price was. So when we divide 144 divided by 1.2, that will be 120. So what that means is that the original price of this item was $120. In other words, if we take $120 and increase it by 20%, we will end up at $144. In this problem, Garrett bought a motorcycle. He paid 5% sales tax. The tax added $370 to the price of the motorcycle. What was the price of the motorcycle, not including the tax? In other words, what was the price of the motorcycle before the tax was applied? So we are only talking about the sales tax in this problem. So here's what we know, that 5% of the original price is the amount of sales tax, which in this case was $370. 5% as a numeric value is 0.05. We don't know the original price. That's what we're trying to find, so we'll use the variable x. And that is supposed to be equal to $370. We can solve this by dividing both sides of our equation by 0.05. We're trying to make 1 right there, which we did. And so when we divide 370 divided by 0.05, that will tell us what the original price of the motorcycle was. And that should be $7,400. In this problem, Antonio uses a wheelbarrow in the shape of a rectangular prism. So what that means is that a rectangular prism, remember, just kind of looks like a box. Now, of course, since this is a wheelbarrow, it will have wheels on the bottom, but that's irrelevant to what we're putting inside of that. To move planting soil to a delivery truck, the volume of planting soil that fits in the wheelbarrow is 4 by 6 by 3.5. So 4 by 6 by 3.5. That's the wheelbarrow. The delivery truck, also in the shape of a rectangular prism, measures 9 feet by 6 feet by 4 feet. So we've got this large truck, and I know this is not to scale, but the truck, which also would have wheels on the bottom, but that's irrelevant to what we're trying to do here. So 9 feet by 6 feet by 4 feet. Antonio puts planting soil in the delivery truck until it is only 70% full. So we're only going to fill that truck. And remember, this is the truck. This is the wheelbarrow. Okay. So basically, we're trying to figure out how many wheelbarrows can we fit inside of that truck until the truck is 70% full. So the question is, what is the minimum number of times Antonio needs to use the wheelbarrow until the delivery truck is 70% full? So in this particular problem, it probably would help us if we could figure out the volume of the truck first. So to figure out the volume of the truck, since this is just a rectangular prism and you first started doing that in 5th grade, 9 times 6 times 4. So that means the volume of the truck of that rectangular prism is 216. But we only want to fill that 70% full. So what that means is that technically we are finding 70% of 216. And remember, to do that, we would multiply 0.7 times 216. And that would be 151.2. So we're only filling up the truck to 70%. So that means we're filling it until it has a volume of 151.2 cubic feet. So now we need to figure out the volume of the wheelbarrow. So that would come from 4 times 6 times 3.5. And that happens to be 84. So technically what we're trying to do is we're trying to figure out how many 84s will fit inside of 151.2. So of course, that means we would divide. And that happens to be 1.8. But the question is, what is the minimum? And I rounded that to the nearest tenth. What is the minimum number of times Antonio needs to use the wheelbarrow until the delivery truck is 70% full? So that means we would need to round that up. So what that means, we would need to fill the wheelbarrow up 2 times in order to get our truck 70% full. In this problem, Jacqueline bought 3 boxes of cereal and 5 gallons of milk for a total of $33.60. Each box of cereal costs $4.20. So once again, Jacqueline bought 3 boxes of cereal. So if this represents each box of cereal, and remember, each of these boxes of cereal costs $4.20. And 5 gallons of milk. I'm just going to kind of get sloppy here. Let's pretend like these represent the gallons of milk. And we don't know how much each of these gallons of milk cost. The total is going to be $33.60. So here's what we know. We know we have 3 gallons of milk that each cost $4.20. Now, instead of writing it down as 3 times 4.20, I could just go 4.20 plus 4.20 plus 4.20. And then we also, if we add to that the 5 gallons of milk that we don't know, now we don't know what any of them are. So this is where typically variables come in. And let's just use the variable x. So we have 5 of those x's, 5 of those gallons of milk that we don't know. That's going to give us a total of $33.60. But the question is, how much is 1 gallon of milk? So, of course, we could then solve that equation. Well, 4.2 plus 4.2 plus 4.2, or 3 times 4.20 is $12.60. So 12.6 plus 5x is equal to 33.6. Subtract 12.6 from both sides. We now have 5x equals 21. Divide both sides of your equation by 5, and we did that because we were trying to make 1 right there. And so 21 divided by 5 is 4.2, so that means each gallon of milk will cost $4.20. Now, it's just a coincidence that the gallons of milk have the same cost as the box of cereal. Most of the time, that would not be the case. And you could quickly check. You've got these 3 that are $4.20 and 5 of these that are $4.20. And if you added all 8 of those up, that should be $33.60, which is what we were trying to make right there. In this problem, a company makes 2 sizes of boxes shaped like rectangular prisms. The large box, not shown, is 45 centimeters tall, 39 centimeters wide, and 38 centimeters long. The drawing below shows the dimensions of the small box. So part A, what is the minimum or the maximum number of small boxes that can fit inside of the large box? So you're trying to figure out how many of the small volumes will fit inside of the large volume. That's one way of thinking about it. Well, the large box is basically a box that is 38 centimeters long by 39 centimeters wide, and then 45 centimeters tall. I could draw that out if I wanted to, but remember, to find the volume of any rectangular prism, it's essentially the length times the width times the height, and that happens to be 66,690 cubic centimeters. The small box, which is right here, is 3 by 3 by 5. So the small box has a volume of 45. So we're trying to figure out essentially how many 45s will go into 66,690. So 66,690 divided by 45, well, that happens to be 1,482. So that means it would take 1,482 of the small boxes. Though 1,482 of the small boxes will fit inside of the large box. Part B, the company plans to increase the width and length of the box by 4 centimeters to create a new larger box. Well, what that means is that we're going to increase this by 4. So now we have 42 centimeters, and increase this by 4, the length and the width by 4. But it doesn't mention anything about the height. So the height will stay the same. So this, the 38 was originally the length, the 39 was originally the width, the 45 was originally the height. The height stays the same. Well, that happens to be, when you multiply that out, 81,270 cubic centimeters. So now, the end question is, how many more of the small boxes will fit inside this new larger box compared to the original large box? So we're just sort of repeating the process here. So we need to divide 81,270 divided by 45, and that happens to be 1,806. So the question is, how many more will fit inside the new box? So that would mean this is the new, this is the original large. So 1,806 minus 1,482 will give us 324. So that means there are 324 more of the small boxes will fit inside the new original large box, or the new large box compared to the original large box. In this problem, Chloe claims that any fraction located between 1/3 and 1/5 on a number line must have a denominator of 4. Enter a fraction that shows Chloe's claim is incorrect. So if we were to draw a number line here, here's 0, 1/5 is smaller than 1/3, and so maybe something like that. So the question is, it says, she claims that any fraction that's between those two must have a denominator of 4. Well, obviously 1/4 is in between those two, but she's saying that any fraction that's located between those two must have a denominator of 4. Well, there are lots of fractions that can be between 1/5 and 1/3, and they don't necessarily have to have a denominator of 4, so you're just trying to give one other fraction in here that will be between 1/3 and 1/5 that does not have a denominator of 4. Sierra rewrote the expression 0.2 times 4 plus 1.45 minus 2.1. She did 4 consecutive steps there. The question is, which statement below identifies and explains the first mistake made? So what you should do is you should write the original problem in the work area, work it out, and then figure out where the mistake is. Well, of course, you're going to use the distributive property and multiply that times that, which happens to be 0.8. And then multiply this times this, and this times this, and so on. And so what you're trying to do is trying to figure out where the mistake was made. So I would, if I were you, I would work this out and totally simplify it first, then read where the each choice you have there, and then from there figure out what mistake was actually made. And obviously, just guessing until you get this problem right is not the greatest strategy.